And of course, when I hit record. So this actually, I think is actually a good thing that we skipped 1.11 because 1.12 relates to what we did yesterday, writing linear equations. And that's all a proportion is, and that's all we're going to be doing today. We're going to be writing more linear equations, except the special kinds. What is the difference between the linear equations that we saw yesterday compared to the ones we're going to write today? Proportional equations are linear equations, so the same stuff we did yesterday, where the y-intercept is 0. So y equals 2x is a proportional equation. Y equals negative 1/3 x is a proportional equation. Basically, any linear equation that doesn't have an extra plus or a minus attached to it is a proportional equation. Graphically, hey guys, let's pay attention. Graphically, it is, wow, I can't draw. It is any linear equation that goes through the origin. So that's a proportional relationship. That's a proportional relationship. That's a proportional relationship. So any line that goes to the origin is a proportional equation. So when it comes to writing proportional equations, which is the topic of 1.12, we have to talk about the different types of proportionality relationships out there. And there's basically only two, right? So here's the phrase or sentence to keep an eye out for. If you read something like this, y is directly proportional, or they could phrase it as varies directly. Right. So those are the trigger words: directly proportional or varies directly. Y is directly proportional or varies directly to x. So if you see or read that phrase, y is directly proportional to x, then we can write the following equation. Bless you. Y equals kx. It basically is slope-intercept form where the y-intercept is 0. It's y equals mx plus b when b is 0. However, since it is its own special thing, instead of writing m for slope, we go ahead and write k for this slope because it has a special meaning. This k, again, it acts as a slope, so it can be any number that you can think of, where k is just any real number. Positive, negative, whole numbers, fractions, decimals, it doesn't matter. The only restriction on k is it can't be 0. Because if k was 0, then you get y equals 0, then it's a boring equation. The other proportionality relationship we can have, or the other trigger words to keep in mind, is this. If, and here's the phrase, y is inversely proportional, or they can say varies inversely. So those are the trigger words to keep an eye out for. 2x. Then we can write the following equation. Y equals k over x. So I am allowing you a note card for Thursday's test. I guess you could put these definitions on it, but it's a rather simple concept. The trick that I use to remember is if anything's directly proportional, in the top definition, notice I'm saying y is directly proportional to x. Notice how y and x, they're on the same level in the equation. In the inversely proportional statement, y is inversely proportional to x. Notice how y and x are on opposite sides of the fraction. Y is on the top, x is on the bottom. So for shorthand, that's the way I remember it. Anything that's directly proportional, when I build my equation, we'll put in the numerator. Anything that's inversely proportional, I put the variable in the denominator. Pretty simple to remember? Okay. Every proportion question, notice, starts the same way. Y equal, whatever the letter is, I'll use y equals k. Every proportional equation should have that k bit. Again, in the context of lines, it's just your slope, but in the context of proportionality, k is called the constant of proportionality. So vocab word there for you. So in terms of vocabulary, that's all we need to look out for. Do I hear or read the word direct or inverse, proportions, varies? I suppose you may hear the word joint or jointly somewhere in this, in the context of school, of course. So if you read the word jointly when they talk about proportions, it's not a special proportionality. All it simply means is more than one relation or variable, right? A proportion doesn't always have to exist between only two things. You could have one variable being proportional to many things at the same time, so they'll just throw in the word jointly in there. In terms of vocab, that's all we need to know. What are my expectations for you? What are my objectives? What are the things I may ask you on Thursday's exam? I may ask you to do one of three things. Number one, can you read? Can you read sentences and translate them into proportional equations? Right. So you may see something like this on your practice or on your quiz. The instructions will say something like, write an equation for the statement. So let's say, here's the statement. The letter A is jointly proportional to the square of x and the cube of y and is inversely proportional to the square root of z. A is jointly proportional to the square root of x and the cube of y, and is inversely proportional to the square root of z. So if I was a student and I had to write an equation for this, I'll just read from the beginning. A is jointly proportional, and I stop. There's my trigger word, proportional, right? Yeah, it has jointly, but my trigger word is proportional, which means I can immediately start with whatever the letter is. In this case, it's A. A equals K. Every single proportion problem, letter equals K. Then what I have to do is figure out, okay, if I have jointly proportional here, what are the players, what are the objects involved in this proportionality? I have the square of x and the cube of y. But then I come up to my next trigger word. Hey, I have this next trigger word here of inversely proportional. So I have to ask myself, okay, what players are involved with that proportionality, which is the square root of z. And then all I have to do is put it in the equation. Again, this should be simple because proportionalities, it's always timesing and multiplying. There's never any adding or subtracting. Recall the idea, anything that's directly proportional will be in the numerator, anything that's inversely proportional will be in the denominator. So since the square of x and the cube of y was jointly proportional, which is direct, I'll put those in the numerator, and then the square root of z, which was inversely, will be in the denominator. Right? Square of x, cube of y, square root of z. There is your equation. There's your proportion equation. Easy peasy. Right? So nothing to solve. It basically is reading comprehension. So that's going to be one of the objectives that we need to master. That's going to be one of the tasks I'm going to expect everyone to be able to do. Not too tough, right? Basically, it's testing you if can you read, and can you put the pieces where they belong. But we got to do stuff with him, and that's sort of the second thing that I'm going to expect you to be able to do. Not only am I going to expect you to be able to come up with an equation, but I'm going to give you information and hopefully allow you to solve it. So this will usually involve the same type of problem, but then they're going to follow up by giving you numerical information. For example, they'll give you this phrase here. M is jointly proportional to A, B, and C, and inversely proportional to D. When A and D have the same value and B and C are both 2, M equals 128. So the first part of that phrase sounds like the previous example. They're just talking about proportional relationships. But the second part of that phrase, they actually give you numerical information. Usually in these types of examples, if they give you numerical information, they're wanting you to solve for k. And as a matter of fact, that's what the instructions will say. Well, not solving for k, but the instructions will be write a proportional equation. So if I give you numerical information, I'm going to expect you to go a step further than the previous example and just solve for k. But you go through the same motions. I'm reading and I notice it's a proportional problem, so immediately I do variable equals k. In this case, my variable is m. So m equals k always. And then I just have to figure out the players involved. I have jointly proportional to A, B, and C. I have inversely proportional to D. Anything that's direct or jointly will be in the numerator. Anything that's inverse will be in the denominator. So A, B, and C on top. D is in the denominator. Pretty simple, straightforward. Because they gave me numerical information, all I'm going to have to do is plug it in. Plug in the information that they give you. So hopefully we can just read that they say that A and D have the same value. They tell you that B and C is 2. And they tell you that M is 128. So just plug all that information in. So I'm going to use this equation to plug stuff in. M is 128 equals, they did not give me any information about K, so just leave it as that. They did give me information about A, saying it's the same value as D, but they didn't give me a number. They didn't say A is 2 or 5, so I'm going to leave it as a variable. They did say B and C are both 2s, so I can substitute those in. And likewise with D, they didn't give me a number, so I'm going to leave it as a variable. But the information they did say is, hey, guess what, guys? A and D are the same number. Notice we have a number on top and the number on the bottom. A on top, D on the bottom. And if they are the same number, they cancel out. So I don't need to know what numbers they are. I just know that they cancel out. And then what is left over is a simple equation to solve for k. That's it. So that's the only other way I can upgrade these examples. I can just toss in a whole bunch of numbers and ask you to solve for it. Divide both sides by 4, you get k equals 32. Right. As I was sort of saying yesterday, if this was a quiz or test, you guys get so antsy and anxious. The moment you get a number, boom, you circle it, you answer it, and move on. The question said, come up with an equation, so that I would have to mark you as wrong. So just take things slow and steady. Make sure you don't move on until you answer the question. The question was to write an equation. My final answer, what I should submit, is an equation. So all you have to do is take your answer here and plug it into your model. So my answer that I would submit is m equals 32abc over d. That would be my submission. Okay? All right. It's just like the previous example, except I give you numbers to plug in. The last example type, the last thing I'm expected to do is a very classical math problem-y stuff. You see this in math classes, you see this on the SATs, you see this on the ACTs when it comes to proportional equations. It's asking to build a proportion and then tweaking the equation. We'll see what I mean in this example. And I hate to make your life miserable. Actually, that's a lie. I don't hate it. This will be a word problem. Yeah. Okay, it's like 2 sentences. All right. Yeah, I know. Too many. So here's the problem. The apparent brightness of a light source, and the problem says the variable we use is capital B, is directly proportional to the luminosity of the light source, which we'll use a capital L for the variable, and inversely proportional to the square of the distance away from the light source. Gee whiz, I wonder what variable we should use for that. What variable should we use for the distance away? D. Yeah. You can use W. There's no law against it. I'll use D. Yeah. So that's the setup. That's not the actual problem. They just gave you information. They haven't asked a question yet. Here's the question. And again, SAT problem writers, ACT problem writers, they love doing these with proportion questions. Here's the question. If the distance is cut in half and the luminosity, that's just a fun word to say, luminosity, is tripled, by what factor is the brightness changed? Okay. So to recap the 3 example types, I can just give you information, ask you to come up with a proportional equation. The second example type, I can give you information, ask for a proportional equation, but then give you extra numbers. And then the third type, I could give you information to build a proportional equation, and then I'm going to tweak parts of the equations by doubling, tripling, halving, quartering, so on and so forth. In either example type, we need an equation. So that's what we're going to do. We're going to read the information and pick out the information. Hopefully we can see the trigger word here is directly proportional. So you start with the variable. In this case, it's B. B is K. And then what is it directly proportional to? The luminosity L. But I do have another relationship, inversely proportional. What is it inversely proportional to? The square of the distance, which is d squared. And I put it in the denominator because it's inversely. Okay. So there's our proportion equation. Let's actually answer the question. If the distance is cut in half and the luminosity is tripled, by what factors the brightness change? Now, the reason why SAT and ACT problem writers love these types of questions is it's purely logic. There's no calculation. You just think about it in your head. Okay, I have this equation. Well, if L is tripled and D is this and K is... I'm going to be honest with you guys, I can't do that in my head, which is why I suggest we write it down. Now, I hope everyone can agree. Do you guys agree that the main focus or the point of the question is to wonder what's happening to the brightness? If that is the case, you want to make sure your equation is solved for brightness, or in other words, it says B equals, which it does, right? If I change the question, which I won't, if I change the question and said, how will the luminosity change? I would need to make sure that the equation says L equals before I do anything. So just keep that in mind. When you set a proportion equation and you actually read the question, whatever variable the question is focusing on, that should be the variable that's by itself. In this case, I'm focused on brightness. Brightness is by itself. This is good. We can proceed forward. So what I'm going to do is I want to know how much brightness changed. So I'll do B prime to indicate this is my new brightness. So B prime equals. And all we're going to do is we're going to follow our original proportional equation and changing the variables that they want us to change. So B prime equals K. K is the constant. They didn't say anything about that, so it leaves us K. Next comes to L. What did they say we're doing to luminosity? Tripling, which we should know is times 3. So this is 3L. Over, in D is distance. What are we doing to distance? Cutting in half, which is 1/2, right? 1/2 D. Notice how I'm using parentheses to substitute. Get into that habit. It makes things a lot clearer. So that's all we did. We just changed the equation based upon the problem. Then just do math. Simplify. Good old algebra, good old orders of operations. So in the numerators, it's 3KL. In the denominator, I hope we know that 1/2 D squared is 1/4 D squared. And your middle school teacher, heck, I told you guys this like last week. When you divide by a fraction, that's the same thing as arithmetically dividing by a fraction is equivalent to multiplying by its reciprocal. So here we have a 1/4 in the denominator. Instead of dividing by 1/4, I'm going to multiply by 4. Question.
How does a half D squared turn into a 4D?
The question was, how does the 1/2 D squared turn into 1/4 D squared? You do know that, so scratch work. You do know that 1/2 D squared, squaring is multiplied by itself.
Yeah.
And then 1/2 times 1/2 is 1/4, and D times D is D squared.
Oh, okay.
You okay with that? All right. Yeah. So, but we didn't answer the question. We just got a result, but we got to answer the question by what factor did the brightness change. Let's take a look at the original proportion, this guy here. Do you agree that this equation says B is the same thing as KL D squared? KL over D squared, excuse me. What you want to do is you want to try to find that guy in your result. And I hope it's very clear to everyone that KL over D squared in our result is right here. That highlight, according to our original proportionality, doesn't that highlight equals B? This whole guy here, this whole highlight should be just regular, good old-fashioned B according to this equation. So I'm going to change the highlight into B. Now look what our work says. B prime, which is the new brightness, B prime, the new brightness, equals 12B. Now we can answer the question. By doing all this changes, how does the brightness change? By what factor does the new brightness change? By factor of 12. There's our answer. But of course, since this is a word problem, just write your answer as one short sentence. I'm not asking for a lot. Just write a little sentence here. So the brightness changed by a factor of 12. Yep. Because our math literally says the new brightness is equal to 12 times the old brightness. Right. So you'll see these types of questions a lot when it comes to proportionality, not only in my class, but maybe in your SATs, ACTs. Hey, here's a proportional equation. double this, triple this, take 1/2 this, what happens to the new variable? All you got to do is just plug in the changes, do some math, and read your answer. Okay? That's it. Those are the 3 things I'm going to expect you guys to be able to do with proportionalities. Set up the equation, plug information in to solve for k, and then change the equation by doubling, tripling, and whatnot. So that concludes 1.12, and that concludes Unit 1. We're done.